Hello students, I hope you are good, well and fine, and today we'll be continuing our discussion on the topic of statistics. Okay, in previous class we learned the definitions. Let me recall you some of the definitions for you, and then we will jump to the frequency distribution and types of frequency distribution such as individual and discrete, and then continuous frequency distribution, and then cumulative frequency distribution. What do we mean by that? So we will be seeing all of these subtopics. So let's begin with the definition, the variate. So variate is the synonyms for you can sometimes refer it as like a variables. Okay, so variables. So variate variable, variate variable. Okay, I hope you can make sense what do we mean by variable. It is a character which can take a value. Okay, so or in variate, the numerical quantity whose value varies in objective is called a variate. Generally a variate is represented by x. I hope this is this is clear. So a number which is capable of taking different value is called a variate. Okay, for example, if you see while surveying a factor, sex, age or income of each worker are three variables. Okay, here sex is a qualitative variable. So if you recall the data classification, we have a qualitative variable, that means on the basis of quality, and income and age are quantitative variable, that means on the basis of quantity. So there are two types of variate. One is discrete, another is continuous. For example, in discrete variate, its magnitude is fixed, and in continuous variate, its magnitude not fixed, it is expressed in groups. Okay, for example, if you see 10 to 20, so that means if you say that there is a student named Arun which has a number in between 10 to 20. Okay, I hope this is clear. So his numbers can take any value, uh, whatever he got in between 10 to 20. And but in this discrete case the value is fixed. So suppose his uh, the number of teacher in different branches of this institute are 30. For say in math there are 30 teachers, in eco there are 35, and in history there are 40. I hope this is clear. Okay, now let's move to the range. So the range means the difference of the maximum and the minimum value of a variable. I hope this is clear. Now the class frequency, is in each class. You will see what do we mean by class, the number of times a data is repeated. Okay, for example, say that number of students whose marks in between 10 to 20 are 3. So this means we have a frequency 3 of this class. Okay, now class interval, this means this is our class or the class interval, that is a group into which the raw data is condensed. So in this example, the it is a group of a number from 10 to 20. Okay, so it is called a class interval. So each class interval or a class is bounded by two figures. So it is bounded by two figures. This is my lower limit, and this is my upper limit. Okay, I hope this is clear, and both of these numbers are called as class limits. So let's move to next. So class limits, as I have already shown you the example. So the lowest and the highest value of the class is known as lower and the upper limit respectively. Okay, so it is respectively, of that class. Now the class mark is the midpoint or the average of the lower and the upper limits of a class. For example, if I have a class 15 to 25, then its midpoint is 20, or the average value of the upper and the lower is equals to, which we know is 40 by 2, which is 20. So both things are same. So the class mark is just a mid value of the class interval. I hope this is also clear. Now let's move to our example. So in this example, the 30 students of ninth class marks are given as follows. So in out of 50, the test was of mathematics. So so if you see, first student got 6 marks, the second student got 32 marks, and so on. So as you can see, we have 30 students. So 1 2 3 4 5 6 7 8 9 10, and 10 here, 10 here, and 10 here. So in total 30 students we have. 30 students marks raw data. Okay, raw data we have. I hope this is clear. Now let's move to make out the information out of it. So the number of times a marks is repeated is called a frequency. We already is seen the definition for the frequency. So it is the number of times the marks is repeated. For example, if you see 0, so marks obtained 0. So 0 obtained how many times, or how many students obtained 0? So if you see, so one student here and one student here obtained the marks or 0. So that means two students obtained 0 marks. In a similar way, 6 marks obtained by 3 students, 26 marks obtained by 2 students, 28 marks obtained by only 4 students, and so on. Okay, so this table gives you the how many marks obtained by how many students. Okay, so let's moving. So the above type of frequency distribution is called ungrouped. If you saw the that example was of ungrouped frequency. Now to reduce the frequency distribution, it can be classified into groups as a following way, and it is called a grouped frequency distribution. So the previous example was of ungrouped frequency, and we can change it into grouped frequency distribution. So this we will see later. So let's jump. So here is our example for the frequency table. So if you saw in previous, so if you saw in previous, we has this, the marks of 0 marks obtained by only 2 students, 6 marks obtained by 3 students. That means if you see the 0 to 6, so the marks obtained 0 from 0 to 6, including we have how many students we have in this class interval. We have 5 students, because 0 marks obtained by only 2 students and 6 marks obtained by 3 students. So in total, if I am saying that how many students are lying in the class interval of 0 to 6, this means I have 2 plus 3, which is equals to 5. So 5 students are lying in this class interval, whose marks are lying in this class interval. Now here the 10, so how many students got 10 marks? So 3 students. So in total, if I am asking how many students are there whose marks are less than and equal to 10, and 0 to 10, or I can say 0 to 10, which is equals to 5 plus 3, which is equals to 8. So in this similar manner, I can make other class interval also. So as it is here, So 0 to 10, I have 8 students. 11 to 20, I have only 2 students. 21 to 30, I have 12 students. 31 to 40, I have 5 students. 41 to 50, I have 3 students. So this means uh, 3 students having marks in between 41 to 50. So their marks can be 41 or 42 till 50. So we don't know from this. If you are seeing only this table, so we can only give information about that 3 students marks are lying in this interval 41 to 50. I hope this is clear. Okay, let's move. So the kinds of frequency distribution, so statistical method like comparison, decision taking, etc. depends on frequency. So if you want to make a decision on the basis of statistics, then frequency distribution plays its main role. As you saw in the previous example, if we are talking about how many students have gotten marks in between 0 to 10, we saw the 8 students. Okay, so in this similar manner, the frequency distribution is very, very important here in stats. So let's see the types of distributions for the frequency. So first one is the individual frequency distribution. Here each item or original price of unit is written separately. In this category, frequency of each variable is 1. So if we see that the number of students who got 5 marks, we have 1. Okay, and got 10 marks, we have also 1. So in this the frequency of each variable is 1 we are taking. So let's move to next. So for example, here the total number or the marks obtained by 10 students in a class. So say first student got 46, we are talking about out of 100. Okay, second got 18 and 79 for the third student, and so on, as you can see the table. So now let's move the discrete frequency distribution. So in discrete frequency distribution, when a number of terms is large, when the number of term is large and variable are discrete, so variables are discrete, we are taking variable as are discrete, that is variate can accept some particular values only. So variate or the variable can accept some particular value. Okay, no class interval will be here, so only under finite limits and is repeated, then it's is called discrete frequency distribution. For example, if you see that here the monthly wages in 4,000, so the number of employees who are getting a monthly wage of 4,000 are 10, and who are getting 6,000 are 8 employees, and who are getting 8,000 are 5 employees only. So here the only single or the discrete values we are taking, no interval here is present. Okay, I hope this is clear, and this is the more monthly wages for other employees. So 11,000 are getting by 7 employees, 20,000 are getting by 2 employees, and 25,000 monthly wages are getting by only 1 employee. So I hope this was all clear. Now here if you see, but in this example here we break down the previous information in intervals. Okay, so we take out the intervals now. So here we are talking about the monthly wages from 0 to 10,000, and 0 and 10,000 is including in it. So the number of employees whose monthly wage lie in this class interval is 23, and for this class interval is 9, and for this class interval it is 1. I hope this is all clear. So one thing is to note here, if variable is repeated in individual distribution, then it can be converted into discrete frequency distribution. So if you So you saw the note, you saw the discrete frequency distribution examples. Now let's talk about the continuous frequency distribution. So as the name suggests, it is continuous. That means the variate is going to be continuous. That means variate can accept all values under finite limits and they are repeated, then it is called continuous frequency distribution. That means we are just talking about, for example, if you see the ages in year, the class and the number of students as seen in this table. If we are talking the age less than 5 years, that means we are talking the about the class which is 0 to 5. Here we talked about directly about the class, so we are talking directly about the class. So the number of students whose age less than 5 year is 72, and for 5 to 10 it is 103, and 10 to 15 it is 50, and 15 to 20 it is 25. Okay, I hope this is all clear. So the class is already given to us in continuous frequency distribution. Take a note that continuous frequency distribution is generally represented in form of grouped frequency. As you saw the example, the all things the variate was continuous, and frequency, the grouped frequency distribution is in was in of the form of grouped frequency distribution, and variate was continuous over there. So for here, the 0 to 5, 6 to 10, 11 to 15, 6 to 16 to 20, like this. That this types of classes cannot be made. Okay, so this type of classes cannot be made. Okay, so let's move to next. Now classes can be made mainly by two methods. So one is exclusive. So first see the exclusive series. In this series we eliminate, or in this method, the upper limit of the previous class and the lower limit of the next class is the same. That means I have a class interval like this and like this. Okay, so here if you see, the upper limit of this class and the lower limit of this class both are same. So in this we have exclusive series. In this method, the term of upper limit in a class is not considered. So if you see this class, I am taking values from 10 say to 19 only, not taking 20, not taking 20. So this value is not included as written over here. Class is not considered, so the upper term of the class is not considered in the same class. So we do not consider this 20 in this class. I hope this is clear. So but in inclusive, in this method, the upper and the lower value both are contained in the same class, or we consider both of the our limits in the same class. I hope this is all clear. So in this method, the upper of limit of our class and lower limit of other class are not the same. And one thing note is one thing is to note here is that the upper and the lower of two uh, classes are not same, must be not a same. Okay, so in the, for example, if we take the 10 to 19, then it must be 20 to something, say 29, and 30 to 39, etc. Okay, say inclusive series. So here we include 10 and 19 also. So we include 19 also, say. Okay, so let's move to next. So here frequency distribution. So frequency distribution, now see the example. So here A, so one is given to us, A, table A. So seeing table A like this, it is the class 0 to 9, the frequency is 4, 10 to 19, 20 to 29, and their respective frequencies are given to me, or one can make like this: 0 to 9.99, 10 to 19.99, etc. Okay, let's move to next. Now we jump to discrete frequency distribution. We already talked about. So from the table of discrete frequency distribution, it can be identified that the number of employees whose monthly income is 4,000, or how many employees of monthly income of 1100 are there. Okay, so in discrete distribution we can easily identify that. So but if we want to know how many employees whose monthly income is up to 11,000, so if one wants to know that how many students sorry, the how many employees are getting the wages or the salary of up to 11,000, so it must be 11,000 here, not 1100. Okay, so then we should add according to the frequency. So in the previous cases, the 10 plus 57, so 10 plus 8 plus 57. So we have to go back to see our frequency. Okay, so for the wages, let's see. Okay, so where is our table? So here, so we talked about so there, so for 100 for 8 we are talking about up to 11,000. So that means we can take this value, this value, this value, 10 plus 8 plus 5. Okay, 10 plus 8 plus 5, and that's it only. So because we are taking up to 11,000, so 10 plus 8 plus 5, and so okay, so here we are 10 plus 8 plus 5 and plus 7 for the we know for this was 10, for 6,000 was 8, and for I think 8,000 for 5, and for 11,000 was 7. So we added all of these frequencies to get the number of employees uh, whose monthly income is up to 11,000. I think this is clear to you. Okay, this is not 57, it must be 5 plus 7. Okay, so 5 plus 7, which is equals to 10 plus 7, 17, plus 8 or 10 plus 8 is 18, 18 plus 5 is what, 23 I think, and plus 7 is 30. So 30 employees are earning up to this much. Okay, so I hope this all is clear to you. Okay, so let's move to next. Now seeing next, that is number of employees whose monthly income is up to 11,000 is 30, as you saw. So here in this we just added all the frequency given to us, and this in this we get a new term which is cumulative frequency. We will be discussing more about this term, the cumulative frequency. Now you have some idea what cumulative frequency mean. It is just the sum. Cumulative means the sum. Okay, so sum of frequency we are talking about, or we will be seeing the sum of frequency, and we will be seeing how we will doing the sum. Okay, so we will get more information out of the raw data. So let's see next. So here now if you see in this, the for the example of the wages of employees, the 4,000 we say the 4,000 rupees is taken by the 10 employees, and similar in other cases is already given to us. Now cumulative frequency means just first of all we write this first term as it is, and then add this and this term to get this term 18, and then again add this diagonal term to get 23. As you can see, our explanation, we don't write our explanation in the table just requires class frequency and cumulative frequency, not this. This is just for explanation, for just explanation. Okay, I think you are clear with that. And for this, just add 23 to 7, you get 30. And now for this, 30 plus 2, you will get this. And now for this is 33. I hope this is all clear. So this refers that the number of employees who are getting 4,000 up to 4,000, number of employees who are getting up to 6,000 are 18, number of employees who are getting up to 8,000 are 23, number of students who are the number of employees who are getting up to 11,000 is 30, and the number of employees who are getting up to 20,000 is 32, and the number of employees who are getting up to 25,000 is 33. I hope this is clear, and how we take information from the cumulative frequency and how we evaluate the cumulative frequency. So let's move next. So now we will seeing continuous frequency distribution. In the previous page we obtained cumulative frequency for discrete. Yes, we did. In the similarly, cumulative frequency table can be made from continuous data. So let's see from the table. So if age is as our variate, we take age from 0 to 5 and we exclude it because it is our example of exclusive frequency distribution. So we exclude it, we exclude every upper term, exclude. Okay, I hope this is clear. And now the age of from 0 to 5, that means the less than 5, the frequency or the number of students we take. So let's say not this employee, it must be students or children's, whatever you want to say, students are 72. From 5 to 10 it is 103, from 10 to 15 it is 50, and so on. Now the cumulative frequency is just quite easy, write the same, add these two to get 175, add these two to get 225, as you can see in the explanation over here, add this to get 250. Okay, so this means if you saw the here be my class. So the class says the age less than 5, because 0 to 5 we excluded. Okay, so less than 5, so we are talking about less than 5, not equal to 5. Here 0 to 10 we are talking about, here 0 to 15 we are talking about, here we are talking about 0 to 20. So the number of students having age in less than 5 is 72, less than 10 is 175, less than 15 is 225, and less than 20 is 250. I hope this is all clear to you. Now from this table, the number of students of age less than upper limit of class, that is the number of students whose age is less than 5, 10, 15, 20, as we calculated in previous slides, can be determined by just merely seeing the table. But if what if we need to find the number of students whose age is more than 0? If we are taking reverse cases or the reverse process, that means the more than 0 or the more than 5, we talked about the less than case, that age, if what if age is less than 5, less than 10, less than 15, less than 20. But what if we want information about more than 0, more than 5, the age is more than 5, age is more than 10, age is more than 15. So let's see how we will do that. So we have our class, 0 to 5, 5 to 10, 10 to 15, and 15 to 20. We have our frequencies to the respective class, and age cumulative frequency, if you see, for in the reverse case, is just we just write here is the sum of all frequency. That is, if you sum, or if you calculate a 72 plus 103 plus 50 plus 25, it will be 250, and this term will be here. Now what we will do, we will be just subtracting values. That first, just subtracting this two value will get me the 178. Now what, now subtracting 178 to this, we will get 75. Now subtracting this value to 50, we will be getting 25, as in this explanation is showing. Okay, I hope this is all clear. So from this we can easily say the number of students age greater than 0 is 250. Number of students age greater than 5 is 178. Greater than 10 is 75, and greater than 15 is only 25. I hope this is all clear too. So this was the end of our session. So thank you for this lecture. We will be meeting again.